talking about velocity and distance and all that. Do y'all remember how that works?
Yes.
So what is the derivative of position? Velocity. What's the derivative of velocity? Acceleration. So we're all good with that? Okay, I am going to introduce a new term, or maybe reintroduce, but talk about this term. Displacement. Luke, can I pick on you?
Sure.
How far away do you live from the school? Approximately.
Probably about 2 miles.
2 miles. Okay, so Luke's displacement today is 2 miles. He left his house this morning, he got to school. His displacement or difference there is 2 miles. Now, if by chance he left his house and he went to Starbucks and got something to drink, and then he went to the gas station, and then he went and picked Ben up and brought him to school, he traveled a lot more than 2 miles. Yeah. His distance is how far he traveled. His displacement is from where he started to where he ended.
Oh.
That's the difference between distance and displacement. Now, how much gas you used would be distance, right? You understand the difference in distance and displacement? So, we're going to deal with displacement, distance, all of that today. You ready to work an easy problem and then we'll work a harder problem? Okay, if I tell you velocity is 5 cosine of t, and we're only looking from 0 to 2 pi. All right? The first thing I want to know, and this is making you remember a little bit, when is this particle moving to the right? When is it moving to the left? And when is it stopped? Isn't it stopped when velocity is 0? So when is 5 cosine of t equal to 0? Do you remember the cosine graph? Remember the cosine graph looks something like this. So it is 0 when t is pi over 2 and 3 pi over 2. Do you remember that? I hope. So when I want to find right and left, I'm going to set up my intervals, just like we have in the past. 0 to pi over 2, pi over 2 to 3 pi over 2, and 3 pi over 2 to 2 pi. Oh, careful. That was his notebook.
All right. So you deserve that. You really deserve that.
What?
So you
No, me, there's the 4.
Do you agree with this? Now, 0 to pi over 2. Don't I pick a value in there and plug into my 5 cosine of t? And I'm saying it's plus. What do you think?
Negative. I think you're lying. I didn't mean that.
I wouldn't lie to you on purpose.
I believe you.
I think this is negative. And I think this is positive. And that didn't answer the question. Because I didn't ask for it was positive or negative. What did I ask? Right or left. And if you answer it positive or negative, it is wrong. So where is my particle moving to the right? And, wait, 0, how about pi over 2? And 3 pi over 2 to 2 pi. It's moving left from pi over 2 to 3 pi over 2. The first question I ask is, where is it stopped? And 3 pi over 2? And it just stops just for a microsecond there when it turns. But it cannot turn around without stopping. Right? Now, my question is, what is the displacement? So, the displacement is where it was when it started to where it is where it ends. Okay? So, the displacement. For the displacement, I actually need V of 0 and V of 2 pi. Okay? What is V of 0? Five. And I think V of 2 pi is also 5. So what is my displacement? 0. Okay. You good with that? So if S sub 0 is 3, what is my final position? If I started at 3, yes. If I start at 3, move everywhere else and come back to where I started, my final position must still be 3.
And the displacement is 0?
Because the displacement is 0. So its final position, I guess I should have written it there. Final position is 3.
So if the displacement was 2, would it be 5?
Yes? Now the question is, what is the total distance traveled? Okay. So what I need S sub 0, I need S sub pi over 2, S sub 3 pi over 2, and S of 2 pi. How did I pick those values?
The interval.
Well, the interval's off velocity. Basically, where it stops, where it starts, everywhere it's 0, and where it ends. Now, do we know S sub 0? 3. What is S of pi over 2? How am I going to find S of pi over 2? Do I need S? So I want the antiderivative of 5 cosine of t. Does S sub t equal 5 sine of t? I don't know why I put a parenthesis there. Right? smart guys. And we did this distance-wise before. What we actually want is this. What is it? 5 cosine of t plus, this is pi over 2 to 3 pi over 2 of 5 cosine of t plus 3 pi over 2 to 2 pi. This, all these have a dt with them. This is what I'm actually finding. Even though before I did it the other way, this is what I'm actually doing. It's the same thing, but now we switched it in terms of integrals. Does that make sense to you? But since it's distance, when I do this, you're going to have to do absolute value, aren't you? What'd you get for this one? Did I do it? Huh? You did it all together? What'd you get? That's, yeah, you got displacement when you did it all together.
I got 13.
I don't think so.
13.
You got 5 for the first one? Not for the whole game, just for the first one. Did you do well?
I don't know. At the first part, I did not do well because I forgot it there. And then I think I figured it out.
Okay, let me ask you a question.
5, yes.
If this is 5, is it this 5? Because weren't they just alike?
It's also negative 5, but absolute correct. It does, yes.
You got to bring those grades up first.
My grades up?
All 3 of you.
What are these?
Anybody get this one?
I think I'm the only.
So my distance is 20?
Okay, so what is this instead of?
What?
You're doing this instead of the S of pi over 2.
We're not just put like 5 sine pi over 2 and 5 sine pi over 2.
Well, you could have done all this.
Yeah.
You would have got this. Well, that's because this really, S of 0 is actually 5. It's where it started was at 3.
That would only be 15. That's 2 pi over 0.
Yeah. 5 times 0, how much is it?
This is 0. So that's 5.
That's not 0, that's 5.
Okay, yeah. I got 5 for a second, like 0.
Sine of pi over 2 is 1.
Let's do this.
Okay.
I can go back and explain that to you, but I don't want to take the time right now. Okay? Somewhere you've got an error in there. All right?
So when we pick the integrals, like integrals for each, do we use
we didn't have to find the S position. We did not have to find this. We used what we had with velocity, and we used everywhere it was 0. And basically, because if you notice, when I graphed it here, this is positive. This is negative, so I had to do it separate so I could do absolute value. And that's positive. Are you all with me? Do you want to do another one of those, or are you good? Do one more, do a harder one? Well, you weren't here for it. You all want to do another one? Can we go a little faster? Can I do a harder one? Well, we didn't do any derivatives, did we? And once again, we're 0 to 2 pi. Okay? Well, my first question is, determine when it's moving right, left, and stopped. Okay? So, I need to know when my velocity is 0. Think a minute. Can e to a power ever be 0? No. So you only have to worry about where cosine is 0, right? Well, I just did that, so it's easy, right? So it's from 0, pi over 2, pi over 2 to 3 pi over 2, and 3 pi over 2 to 2 pi, right?
Yeah.
Type it in your calculator. Tell me each one, is it positive or negative?
Just so we did it long.
Yes. I think this was positive. Right? What was this?
No.
Oh,
I got positive negative.
positive. This is positive. I don't know what happened there. Okay. So, when is it going right?
From 0 to 5 to 3 pi to 3.
When's it going left? Pi over 2.
3 pi to 5.
When is it stopped?
Pi to 2.
And that is not an interval, is it? My next question. Find the displacement.
Didn't we already do this stuff?
Some of this, yes. The displacement, the easy way to do displacement is this.
Oh, that makes sense.
You're finished, Harrison? Are you finished? Okay, the way you sent it yesterday worked good, so send this one. I'm recording the lesson, and I will see you online on Monday, okay?
We miss you, Harry. So much stuff's happened now that you're gone.
Bye.
I miss you, Harrison.
All right.
I feel him in the boy. Harrison, I miss you. Say it back. Say it back.
This is the easy way to find displacement. And why? You can plug it in your calculator. Tell me why that looks hard.
Well,
I
when
got
it gets on the new calculator.
Something has a negative 14.
Zero.
You got 0?
Yes.
We'll see if that's right there.
Okay.
Sometimes I don't trust it.
So the displacement, once again, was 0. Its original position was 3. So where is it at 2 pi? 3. Agreed? Now what are we asking for? The total distance. 0. The total distance is going to be 0 to pi over 2.
Is that the EOS?
Of e sine of t cosine t dt plus the same thing pi over 2 to 3 pi over 2, right? Plus 3 pi over 2 to 2 pi. Cosine t dt. By the way, we could take the antiderivative of that. No, it doesn't, because if u is sine of t, isn't du cosine t dt, so all I have is the integral from e to the u. And then e to the u from 0 to, what's sine of pi over 2? 1? So e to the u from 0 to 1.
Yeah, I got negative 7.064 for negative 14. Is that basically 0? That's not it.
So when I want the total distance, I do each integral,
Yeah.
right?
So what is the point of antiderivative if you're just using the integrals?
You don't have to take the antiderivative on this one.
So why do we do that?
To solve the integral.
Well, to solve the integral rather than typing it in your calculator.
Well, that's what we tried to do last. So we don't need to do it, but we did it.
No, yeah, you translate it.
Well, you do need to know how to do it, because what if this was a no calculator problem? What did you get? Anybody get an answer? 4.7? Okay, this is what I got. If you did it by hand, this is what you got, 2e minus 2 over e.
I do all this so fast.
Well, the first one's just e, and these two are the same, so the second one's e.
How do you know those two are the same?
Okay, I'm not answering that. I need you to go to page 386. We have extra security. You are fine. And honestly, at this point, I would think that probably, if they're going to shoot somewhere, it's going to be at the elementary, because that's where it happened.
Yeah, yes. We're mad at you guys for keeping that gay person.
Well, now wait a minute, she was 8. You don't call her a gay person. Okay. What is the distance traveled on the very bottom of the first column on page 386? What is the distance that particle traveled? 33. Okay, now, looking at the graph, where do you think the particle achieves its greatest positive acceleration? This is a picture of velocity, a graph of velocity. Acceleration is the derivative, correct? Which means it is the tangent line. So what I want to know is, where do we think our acceleration is the greatest? Okay. What about on the interval from 0 to B? At A? All right. Now, go to problem 17 on this page. 17. All right. We have a graph. If you notice, do you see the graph? The question is, find where the particle is at the end of the trip. The particle starts at x equals 2. Read the directions. When t is 0, it starts at x equal 2. Where is it at the end of the trip? The end of the trip, it is adding together the area under each graph. So is each graph have 1? Right? So how far did it go, or what is its displacement? 4. At the end of the trip, however, it is at 6. Do you agree? If it started at 2? So my first question is, where is it at the end of the trip? It's at 6. What's the total distance traveled? It traveled 4 units. Correct? Go to 19. Go to 19. I want to know, where is it at the end of the trip? It started at 2. When we find out, what?
It's going to be at 4.
Well, it can be trapezoid, or could it be a triangle and a rectangle?
Or where it would be.
Triangle is 3.
But this.
The rectangle is. We got some negative.
Right.
Rectangle is 2. You got 5. I'm thinking it's 1, 2, 3, 4. You got 3, 4, 5, 1.
When we're finding where it is at the end of the trip,
So it would be X.
Okay, it starts at 2, right? So basically, the final position is 2 plus the integral from 0 to 7, right? So it starts with a -1, correct?
Ends with negative also.
And then how much is in the top piece?
5.
So I have 5 minus 1 plus 5 minus 1, right?
Yes, it's the 3. Travel 3 ends at 5.
I said that wrong, didn't I? It started at 2, then it did a minus 1, then it did a plus 5, then it did a minus 1. Where is it?
5.
5. Right? Are you good with that? What's wrong? Okay, looking at 19. Yes? Isn't the first triangle -1?
Okay.
And then the trapezoid is 5. And the second triangle is -1. Right? So I just add it all together, plus 2 I started with. So where is a particle in the trip? At the end of the trip is 5. What is the total distance it traveled?
3.
7. Distance is absolute value. Does that make sense?